Okay, here we go. Quick and close. Have a look, please. So, I want to talk about. We're not going to do the whole thing, but I want to just introduce this idea today. It's a big, really important idea. It's a statistical thing, right? So this is totally different than anything we've done. This is just to kind of ease your minds here. This is not really algebra stuff. I mean, it's applying algebra in a way that people really use all the time. So the concepts we've been talking about come into play, but this is something where you're going to let technology do all the work for you, right? So the example, I'm just going to pull one of these questions up as an example here. Let's just take one like, let's see, what page is that on? Yeah, I got so many pages open, this is crazy. Right there. Okay, so let's look at something like this. You know what I mean? I'm gonna do one of these. Okay. So here's a problem. You're gonna do a problem like this. There'll be a bunch of different possible ones you could get, but this is an example. I like this problem because you're given a data set and you've just got to use the data set to come up with something real, okay? Okay, so let's look at this question. What's this saying? We just took this is average movie ticket price based on some data. And is this exact? No, I kind of made these up, but you get the idea. They're pretty accurate. They're based on actual data. So it shows you average price of a movie ticket, so we'll call that P of T, based on the year T. So for each of these years, it's giving you the average price of the movie ticket, right? And it's asking you, rounded to 2 decimal places, what would be the best prediction for what the ticket price of a movie is going to be in the year 2083, based on this data? Okay. Well, that's way out there.
Wait, 2083?
2083, so it's way out there. Okay. Yeah, a couple things. So, first thing we're going to do here, we'll get to the second part of the question in a bit, but the first thing is we want to come up with an idea of what is the function that's going to best model that data, right? So we're going to go into Desmos, and if you want to do this with me, that's fine. If you want to, open up the Desmos graphing utility and go along with me, that's great. If you don't, that's fine. You can just watch. I'm going to grab it though. Okay, and here's what we're going to do in the Desmos graphing utility. We're going to make a table. So how do you do this? Now you can do this on calculators also, and I will show you how to do this on a TI-84. But I'm not going to do it today because it's a little bit of a process, and honestly, I mean, Desmos just is so much better. It really is. It does everything for you. You always have access to it. You can download an app on your phone. You guys know that, right? Okay. Or you can just go to the site on your phone, but you can also, on a computer, you can do a lot of stuff with Desmos. That's really simple and easy to do, very effective. So if I want to make a table, I go up to the little plus sign to add an item, and I go down to table. Okay? And it pulls up, look what it does. It pulls up, it looks like a table. It gives me this little icon up here, means it's going to be a scatter plot. That's what I'm going to get if I graph this. I'm going to put in individual data points. These data points don't exactly match what the variables are here. Instead of X and Y, we have T and P. You can change those if you want to, but you certainly don't have to. We could just know, if you don't want to go through that hassle, and I'm not going to, we would just know that the input is going to be X and the output is going to be Y. But I could go change those headings if I want to, make it look good, and make it be a T and a capital P. And then all I'm going to do is I'm going to input, my input values are going to be, you know what, I am going to change it. Why not? I'll just make that a T, and I'm going to make this a capital P. Okay? And I'm going to, for all my T values, I'm just going to put those in. So 2012, And then if I do, Desmos is kind of nice. If I go 2013, now it'll know that what the pattern is. So I'm just going to go up to 2018. And then I'm going to go over and put in my data. For 2012, it's $7.79. Next I get 8.25, 8.47, 8.43, 8.57, 9.01, 8.96. Okay? And if I want to graph that, oh boy, how do I graph that? I wonder if that's going to show up. Well, that's like way the heck out there. I got to go really, really far out this axis. So if let's see what happens if I zoom way, way, way out. Okay, they do show up. So. So way in, there's my data. Okay.
What if you just took up the 20?
I could, and I could do that. I didn't on these problems, but you see what? What if we do that? What if we just take out all the 20s? Just to make things a little bit easier to find the data. But that's going to change our regression model. So you can't do that on the homework, because on the homework, the input values are actually the years, which I think is better in a way, because then you don't have to worry about changing the years into some other variable. You just put in the raw year and it gives you the right answer. But just to make this a little bit easier to see what's going on, we'll say that the values are the number of years since 2000. Okay? That's our input year, the number of years after 2000. And now if I go home, I don't have to zoom out very far and I can see my data. There it is. Okay? So what do you notice about that distribution? Talk to me about that distribution a little bit.
Looks like a bird.
It looks like a bird. Okay, true. Does it line up? Does it fit perfectly onto a line?
No.
It doesn't. But it's basically pretty linear, isn't it?
Yeah.
Right? It's a fairly linear trend. You guys have probably talked about a best fit line before, maybe back in Algebra 1, way back in the day. Okay. So when you talked about a best fit line, did you go through and you probably graphed them with pencil and all that, right? Did you do something like that? Remember doing that?
Yeah.
And you try to, what's your goal when you're trying to come up with a best fit line? When you're going to draw a best fit line, what are sort of the rules you would identify? Okay, so you want to have the same number of data points above and below the line. Very good. Does it have to go through any individual data point? Doesn't, right? In fact, in most cases, the best fit line probably never passes through any of the individual data points, right? It's unlikely that it will. It could, but it may not. The other thing is, if I want to have the same number of points above and below the line, I'm sure you get this, but like this would be a really bad choice, wouldn't it? If I were going to do something like that, if I made my best fit line, like that. That's a pretty crappy best fit line. I got the same number of points above and below, but it's not very good, right? How come it's not very good?
It doesn't really
Because
follow
it
the line.
doesn't, like,
Okay.
it makes a lot of extremes, it makes a lot of outliers.
Okay, we don't want a lot of outliers. We want our best fit line to follow the trend. And so not only do I have the same number above and below, if I were going to take, that's a little better, right? It's not very straight, but you get the idea. In any one part of the graph, any part that I grab, like over here, I've got some above, some below, some above, some below, some above, some below. Get the idea? So it's going to follow the trend, but it's going to have roughly the same amount above as below, right? Okay, now what's the problem with drawing these things by hand? I'm not going to have you do any of these by hand. You'll never do it again. We don't do that in math anymore. Human error. Everybody's going to have a slightly different interpretation of what the best fit line is, right? So does that make it a very good model? Not really, because think about, if we're going to extrapolate this line all the way out to, 83, right? To the 83 years after 2000. If Grayson draws a line with a slightly different slope than Aiden does, if I trace that all the way out to 83, those lines are going to diverge quite a bit, aren't they? You guys are going to make pretty different predictions.
Yeah.
We don't like that in math. In math, we want to have uniformity. We want to have the same, we want to have a model that makes the exact same prediction every time, right? So we don't draw them with paper and pencil anymore. We do something very different. Here's what we do. We're going to let technology use what's called a regressional model and do this for us. So I've got all this data in there. All I've got to do is I'm going to go down to the next row, and I'm going to say I want to find out what the regressional model is that's going to predict the price as a function of year, right? So I'm going to do P sub 1 because that's the heading of my output data, right? P sub 1 is approximated by, and so what I use is a tilde. It's going to be the shift, and then it's the key right to the left of the number 1. It's that symbol. Okay? So P1 is approximated by M times T1, like MX plus B, only instead of Y and X, it's P and T, right? So MT plus B. Now look what it does. It does something truly amazing here. It's going to take all that data that we just input. Let me make that a little bigger so you can see that just a
How
little
do you
better.
do the sub thing?
The sub thing, so if I just type P and then a 1, it knows to put that as a subscript, okay? That's the pattern Desmos follows. But look what this did. It says I'm going to take this as my output data, that's my input data, and if I model that with the line MX plus B or MT plus B, it is the line that best fits the data using a regressional model, which is called the least squares fit. And I'm not going to go into what that means today because I don't want to bog you down with that idea, but we'll talk about that later. It tells me that the slope of the best fit line is 0.183214, and we keep going, but it rounds it to that many places, just for visual purposes, right? Because otherwise it's too cumbersome to write. The y-intercept of the best fit line is 5.74893. Okay? So there's two different kinds of questions on Moodle. One of them is going to ask, I just want you to come up with, for some data, I want you to write out what is the best fit line. Okay, so for us, that would be, let me just capture this data with a screenshot, and I'll show you what that would look like. Okay, so what's that stuff telling us then? That's telling us that our yeah, it tells you that the best model is P of T equals that slope. Now, we don't want to write that whole thing out to a billion decimal places, right? So in Moodle, when we're writing out the regressional model, I just told you to round all the coefficients to 2 places. So that would round to 0.18 T plus B, which is 5.75. Okay, that make sense?
How do you, when you
That's-
put, when you put in the thing with the squigglies, how do you get it to show up? Because George and I didn't catch that.
Yeah, like the parameters.
Like the statistics.
It just shows up right below it.
It didn't, oh. didn't
Okay,
do that
so
for-
Let's just stay
We'll
and keep working.
hold this thought. We'll wrap this up tomorrow, and I'll put up an assignment for you on it. I'll give you a day to kind of catch your breath and finish the other stuff, though.